Okay, you guys, so what we're talking about today is the unit circle. So a unit circle is going to be, it's a super specific circle that has a radius of 1. So here's some points on the circle. So if we think, so here I have this circle, it's centered with the origin. And if my radius is 1 everywhere, so your radius, we're going to kind of combine what we know about angles that we learned in the last section. But so if your radius is 1, no matter where it is, you know that this point right here would be 1, 0. Okay, because here's my radius of 1 unit in length. Yes, Brady?
I have a question.
Oh, you just looked at me. Okay, then up here we'd be at 0, 1. Because if I keep swinging my radius of 1, over here I'd have a point at -1, 0. And then down here, this point would be at 0, -1. Okay, so those are all of your points on your unit circle. Then you know like your distances, so from one side to the other side, you go from -1 to 1, so like this is your domain. And then your range, you go from -1 to 1 for your y's. Okay? So, yeah, Carter?
You want us to fill this out on the circle thing?
I'll get to a slide and then I'll tell you what to write on that. So don't write that yet.
Oh.
Yep, don't write on there yet.
Okay.
Yeah, so they're not a, well actually those, no, don't write those.
No, okay.
Sorry, don't write on your unit circle yet. Those that you did write on there should be okay, but yeah. What the unit circle, those are gonna be sine and cosine values, not coordinates, okay? So we're gonna progress from coordinates to sine and cosine today, okay? Okay, so then this picture over here, so you can have any point on here. So any point on your circle, if you think about it on like a grid, so it has an XY coordinate, and what your book is gonna do, it's gonna call it T. So you have some T point, so if I have this point up here, I know that it has some X coordinate or Y coordinate, or we're gonna say that the point is at T. Okay, and then you can go from any angle to that point, and you're gonna know that this radius is still 1. Okay, so we know all of that, we're given that information. And then we know with angles, we always start at our x-axis, and we go from there. So then we would have some angle theta. Okay, so that's all given information that we know.
So that circle with the 0 thing, or not the circle with the 0, the 0 with the line is like theta?
That's theta.
Theta?
Yep, so it's just a Greek letter. And we'll see it, they use it for angles a lot. So just like how we use x for numbers, theta is gonna be for angles, okay? So same thing, it's just a variable that we'll solve for. Okay, so then looking at in terms of trig functions, okay, so I know it's been like, we haven't really talked about trig stuff like much at all, like maybe you did in geometry, but it's been quite a long time. Okay, so trig functions, it says, so our definitions, it says, let t, so our point, we're calling it t, be a real number, and let its x, y coordinates be the point on the unit circle corresponding to t. Okay, so when I have my sine of a point, that's just gonna equal my y value. Okay, so right here, at this point right here, if I ask you what the sine at that point is, whatever its y value is, that's what its sine is going to be. Okay, so sine corresponds to y. Well, then cosine corresponds to x. Okay, so cosine goes with x, sine goes with y, which is why this picture of this circle, it looks like we have a ton of different coordinates. Like all of these look like they're coordinates. And I told you we're going to put sine and cosine values in there because sine and cosine are x and y. Okay, so cosine is x, sine is y. Okay? So then tangent, because maybe you know this from geometry, maybe you don't, but tangent, we know that tangent is equal to sine over cosine. So because it's sine over cosine, it would be sine we said was our y, and cosine we said is our x. So we'd have y over x. So if I ask you to find your tangent at this point t, to figure out that, you would just take your y over your x. So then these are the three main trig functions, sine, cosine, and tangent. but each of them has one that they're kind of paired with, okay? So this whole chapter, we're gonna be talking about all 6 of them, but these are the 3 main ones, and then they have one that they kind of get paired with, okay? So sine and cosecant go together. Okay, so the way I remember that is that the sine and the secant don't go together, the s and the s can't go together, if that makes sense. So it's like sine and cosecant are paired together, and cosine and secant are paired together. And when we get into graphing these, we'll see how those graphs work together. But we're not graphing these today.
So S's can't go together and C's can't go together.
Right, so that's how I remember which
So they're
ones.
just like the reciprocals of
Madison, thank you
Mhm.
for
it? Like
telling me
they're
about that.
switched, like y over 1 and then 1 over y?
Yeah. Yeah. Kinda. Right now we can think that, sure.
What did you say?
Kind
Jasmine asked if they're reciprocals of each other, and like kind of, but like graphically no. But equation wise, yeah. So kinda. Okay.
They're just not identical things.
They're what, Shannon? Yeah, they are weird. And then tangent and cotangent go together, okay? So tangent, cotangent, those two sound the same, so tangent, cotangent, they go together. Sine, cosecant, because S and C, and then cosine and secant, because can't pair S's, can't pair C's, okay? Okay, and then, so yeah, so if I asked you to find your cosecant at that point, you would just do 1 over the y value. If I asked you to find the secant, we'd have 1 over the x value. Obviously, we can't ever divide by 0, so those bottom values can't be 0. So sometimes you're gonna have undefined values, okay? And then cotangent would just be, instead of, for tangent, we had y over x. If we flip them, just like Jasmine was saying, kind of doing like the inverse, we have x over y, okay? All right, questions on this?
Should I write down the tan equals sin?
I probably got that on another slide in just a sec. Okay, so the unit circle. So there's some specific angles on our unit circle, hence in your picture you have like all these specific angles. But it says using the unit circle we can find the x and y coordinates of any angle, but the specific ones that we're gonna use for most things are gonna be on that circle. Okay, so every quadrant, because we're gonna use reference angles quite a bit, because these angles right here are the same, but they might just be negative in the other quadrants. Okay, so I know this is a lot, guys. Okay, so, but if you learn like your sine and your cosine, and like your radians and your degrees for the first quadrant, all you have to do is make them negative in different quadrants, and we'll talk about that, okay? So really you just have to memorize the first quadrant and you'll know the rest of the circle. Okay, so in our first quadrant, the first specific angle, I still wouldn't write on the circle yet. I'll put a slide up that has the whole circle so that way you don't mess anything up.
Do
Okay.
we need to write this in our notes then, because that's gonna be in our.
It'll be on your circles, so you're okay. But yeah, so the first specific angle, this one is pi over 6 in radians or 30 degrees, okay? That's like an angle that gets used a lot. Then right in the middle, we have pi over 4 or 45 degrees. And then this angle is going to be pi over 3 or 60 degrees. Okay, so those are the main angles that we're going to learn: sine and cosine and tangent and cosecant and secant and cotangent. All of those 4. And then we'll use those all the time, okay? So now your circle for you guys. Oh wait, we're not at the circle. Here you go. Fill your circle out, guys. Yes, sir.
Oh boy.
Oh.
No.
I mean, you can just give it a little bit.
Yep.
And then
Okay.
you go 90, then you go 180, then 360.
Huh, I was
Is that where it starts always?
Yes.
Like
Okay.
that?
Yep. So if you want, I can help read these to you. So
Is it legal to walk up there?
yeah, come sit up here. So these are so you need to know both your degrees and your radians, and then remember your x coordinate is your cosine there, and the y coordinate is your sine value there. Okay. So those are x and y coordinates, but really we're going to talk about them as cosine and sine. Do you want me just to read the degrees and then read the radians and we can all do it together?
Yeah.
Okay, ready? So starting here, you always start at 0. You're okay? Okay. Well, I don't know if people have bad eyes or not, so.
I got
Okay,
it.
make sure you make, in the first
Watch me
quadrant,
mix up these.
everything is positive. In the second quadrant, your x values should be negative. Third quadrant, everything should be negative. And fourth quadrant, it's your y values. Because if you think about this, if you were to put this on a grid, like these are your x and y axes, well, everything's positive here. Your x values are negative here. Everything's negative, and then these are just y values are negative.
Why
Okay,
is
so you
there
can.
so much pop?
Why is there, yeah, there's so much pi and there's so much square rooting in the x's. I just,
Every radian measure is always gonna have pi, Carter. So every time you write a radian, you should have pi in it.
Okay.
And we're mostly gonna use radians, okay? And
He
then,
sounded so unsure about that.
and the square root reason is because these all come from triangles. And we'll talk about that, okay? But I'll let you guys just get all this.
Honestly, the world would be so much better without triangles, though.
and circles and shapes. Math.
Man, Cal's been so curious.
That's
But you guys know, an exciting thing, we're gonna watch a video today, so that's kind of exciting.
No, it's not.
Yeah, it is, it's like a 12-minute video that we get to watch about.
Brady and I are going to Trump after this class.
You're gonna
Wait, what?
Trump?
No, we're gonna go to Trump. We have a new education system that, we're gonna, it's about pitching.
What's pigeon?
I'm getting rid of Trig.
This is the best
They're
class.
comparing us. I don't know about that.
For certain people.
Okay, in our defense, though, she is like the best teacher that we do have, that like teaches for classes.
Thanks, guys.
There's only one other.
Oh,
Too bad you're
wow.
leaving. Too bad you're leaving.
You're also leaving.
After that
No.
bow, I think it's okay.
Should I
Yeah.
write that on the sticky note?
After that.
Oh gosh.
Okay.
I'm just kind of
I
ready.
gotta go.
Do you want us to
Are
go
you
to
ready?
Jasmine?
I'm ready.
I'm just.
I
Well,
really
I mean, I have the
don't know
first one
where I'm
down,
at.
that's all you need.
Why are there so many
They're not lining up.
Pretty, that's all you need. Gets halfway into the year.
Yeah, why?
Why do we only have the first four written?
Because they all come from triangles. Because if you think a squared
No, I
plus b
hate
squared
triangles.
equals c
Do all
If
squared.
I'm using the
Oh,
standard, I
that's
should
zero.
be able to read this.
Yeah, you're gonna use this for your whole year, so write it neatly, don't mess it up.
Yeah, but it's
Why are they all over 2? Like, why is that 7?
We'll show, we'll do all the math, don't worry.
So, question.
Rather not know.
Are we learning all of this into one section?
We have 3 days, so,
Yes, that's a yes. Just answer my
How many days do you get for that homework?
so
Four.
3 days
Oh.
till we do. So we'll go on to section 3 on Thursday. Okay.
Blake, I'm sorry.
Is
you
it
have to
notes all
learn
day
this.
tomorrow?
Yeah.
Well,
Poor
there's really
Blake.
not that much left. We'll watch a video and then we'll do some examples.
I
And
get
then
to sing another
every-
cool song.
No song.
Uh,
Instead, it's called the left hand trick.
No,
and it
Carter,
like
shut up.
helps you memorize all these numbers.
We don't need
So,
that.
because you figure it out by like.
It's all of this thing.
We should learn like
Yeah.
Japanese or do something kind of math
On the other side.
because they have really cool techniques. Do you ever see the
I
TikToks
don't know.
over Japanese math?
Yeah, like with the lines
Why
and
would,
stuff.
why
It
would
is
we-
so simple. I mean, I haven't learned it or anything, but it looks really
It
easy.
probably takes a long time.
Yeah, I bet you this looks really easy to them too.
Brady?
Okay.
Oh my
Okay, why?
I thought we were past that.
Pretty. Why is that?
I'll never be past that.
Oh, no.
So there's not a 360?
No, is it be a
That's 0. So 360 would,
Brady.
this one could be 0 or
Brady.
360, but you start there, so you usually do it at 0.
You should have just pulled a Noel Miller and just not give out your just like
Without this, I'd be living life.
You can tell.
You should use what's under your typewriter.
Brady, I'm sorry. I just had to say that.
I
thought it
honestly, I'm
would
gonna
be
be honest with you,
funny.
I think I'm getting
Yeah,
this
you
wrong.
I've dealt with it too much to give up.
My eyesight's not the greatest.
Yeah,
Well,
Brady,
you
I'm
can always
just-
check on, my notes are up on school, so you can always double check.
Why
Have
isn't
you
there
not
one
seen
for
the new
this
Glitch
bottom one
stuff?
over here by the 0 and make like this one? Is not up to
This is all, oh, that's line, so this is, yeah. It's just like,
I understand all of this.
so this is an angle, no, it's not a section, it's the.
Oh, yeah.
I wrote the like
One perfect pi.
Stem blade.
From this quadrant.
Yep, because you start here, so then it'd be like your angle from here to here is
Always
pi
start on the
opposite.
x-axis.
Yep.
And then,
Yep.
and then because they're going that way.
Maybe we should just do that.
Do it again.
Right, because this is, if you think
I
this
don't
is
wanna
your
be
y
that
axis
guy.
and this is your x axis, well down here, well these
You
are.
need to go
these
now.
are negatives. Yeah, that
Get out of
is.
here.
Okay.
Wait, where are we going? Can I join down here?
Not control the new school system. Brady's doing it.
I think the more people come, the better, but.
Alright guys, as you get these filled out, let me know,
Can I make like 8 copies of this?
when are you gonna lose it?
There's possibility.
Well,
Yeah.
sure,
Go
make a
make
copy
8
of
of them
it.
because you might lose it 7 times.
Nah, he'll lose at 8, but it just won't happen anymore.
So a new study has found that the leading cause of stress and anxiety in high school students is actually Trig.
Oh, yeah.
Yeah.
I don't think so.
No,
Is that
Brady, you
one
say it
pi?
wrong. It's not
Or is
stress
that
and
11
anxiety.
pi?
It's just
So that's 11 pi.
that in general.
The number one leading cause of death is Trig.
Don't we have the same, like,
Be careful.
Yeah, what you say.
I don't.
no, it's fine.
Are you thinking of
That might sound
standards
dumb.
for like? Yeah, that's what I was thinking.
Alright guys, we're gonna move on, finish those, finish
Jen,
writing.
say what you were gonna say.
I'm so confused.
Be careful. No, no. I wasn't gonna say it. I didn't know what it was. No.
Was that what you said?
I'm sorry, John.
No, I did not know what you said. I just heard be careful.
Don't we have the same what?
What is that?
Don't we, it's, I don't know, I saw this fact or whatever.
11
that-
power 6?
No, it was one of the WTF facts, you know, and we have the same like mental,
Capacity.
no, mental something as the,
State?
no, yeah, sure, mental state as the psychiatric patients in the way back.
Like the 50s?
Okay, so remember what I said?
I don't know what you said though.
I have the mental
I just heard the
capacity.
be careful.
Yeah, be careful.
Yeah, I'm good. You might
Because Aaron
Oh,
is
gosh.
definitely
Okay.
somebody.
You just switched the negative signs.
Yeah. Alright guys, so here is our definitions of trig functions in terms of triangles, okay? So because we know that all of these angles, this makes a triangle. So every single thing on your unit circle, every one of those lines, that makes a triangle back to where you start your x-axis. So all of these come from the triangle, okay? So you can always just take your triangle. You know that your hypotenuse is always gonna be 1 because this is a unit circle and our radius is always 1. So, say I'm trying to solve for one of these values, I know that sine, if you think of SOHCAHTOA, like sine is gonna be your opposite over your hypotenuse value, okay? So looking at your angle that's gonna be in at the origin, you would use your opposite angle to that, so this would be my opposite. And then my hypotenuse is gonna be 1. And then if I need, for some of them, this is my adjacent. Okay, so when we get solving some of these, you might have different numbers in different places, but we always know if we're solving for sine, we just look at our triangle and we look at opposite over hypotenuse. That's gonna be that ratio. Okay, so if we think about, we said our sine is equal to our x value. So like this point right here at 1, 0, this right here isn't really even an angle. It's just a straight line. So if I think like my opposite, so here's my angle opposite that would be, would be like 1, because from here to here would be 1, over my hypotenuse, which would be 1. So 1 over 1 is gonna give me my sine value of 1. Okay, so this is how all the triangles tie into the coordinates that you just wrote around your unit circle, okay? And then once you know the three main ones, so sine, cosine, and tangent, so we know that sine opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent, you can say tangent is opposite over adjacent. It doesn't say that up there, but so tangent is opposite over adjacent, or it's the same thing as sine over cosine. Because most of the time we're gonna be going from our unit circle, and we'll have the sine and cosine values, so if I tell you to find tangent, because you don't have tangent written on your unit circle. So if I asked you to find your tangent at 45 degrees, you would go to 45 degrees, and then write your sine over your cosine, and simplify it to get your tangent. So far, so good.
Would that be the same thing with cosine?
Yep, so that's gonna be the same thing with cosine. So all of these ones are just gonna be flipped. So if you start with what your sine is, you know that your cosecant, because those two work together, if you find this number and it's some fraction, you can just flip it, and that gives you your cosecant, because it's your hypotenuse over your opposite, or 1 over your sine value, and when you simplify it out, it's just gonna be flipped, right?
What would a sine value be?
So those are like what you wrote around your circle. So your sine, like at this point right here, we can pretend that this is 60 degrees. So our sine here and our cosine, what'd you guys write at 60 degrees?
What is sine, what is cosine?
So we said, we learned cosines are x.
Square root of 2, wait, hold on.
1 over 2.
1 half.
1 over 2, and then square root of
3 over 2.
Yep. Okay, so my cosine value is 1/2, because we said our cosine is always our x.
Okay.
And cosine, we know is gonna be our adjacent over our hypotenuse.
So if it's just, so it'd be something over 1.
Right. We just don't have that other value, so
Oh,
even though it's
okay,
over
so it's
1,
not-
it simplifies over to 1/2. So right now where we're at, we don't know that other value.
Oh, okay, so the question is gonna tell us. Like,
Yeah, yep,
okay.
exactly. It'll like give you the
I was just
information.
really lost where you're pulling some numbers from.
Yeah. Carter?
What is the circle with lines between five?
Theta. This just
Right.
represents any angle. It's just it's just like x,
Theta.
but we use it for angles. So, yep, that's theta.
It's the Greek god of confusion.
Okay, sorry guys, I know that this stuff at first is really confusing, but after like a week or so, you guys will be like, oh, we're good, okay? So, okay, so yeah, so all of
That's
these,
funny.
if you can figure out the sine, cosine, and tangent to get these other ones, because they have the one that they kind of go with, that they're paired with. So your cosecant, like I said, you just flip your sine value. Secant, you just flip your cosine, and cotangent, you would just flip your tangent. Okay, so like right here where I have my cosine of 1/2, so my cosine is equal to 1/2. So then my secant, because secant and cosine go together, all I have to do is flip it, so it'd be 2 over 1, or just 2. So my secant at 60 degrees is gonna be 2. Okay? Or like my sine value at 60 degrees is equal to that square root of 3 over 2. So then because sine and cosecant go together, I'd have my cosecant is equal to 2 over the square root of 3. So you just have to flip them. Okay, so once you figure out the first 3, you should be able to figure out the second 3.
What's COT?
Cotangent.
Wait, hold on, so
So
Cot.
sine, cosine, tangent, cosecant, secant, cotangent. Okay, but you won't ever see them written all the way out.
So
Like,
it's cosecant and secant.
yep. Bless you.
Thank you.